Hello, Mr. Stoller here. So today we are looking at we're going to be finding angles and sides. Okay, still on trigonometry, grade 10. Now let's look when what we supposed to use when we what call maybe let's say if you're given two sides, use Pythagoras theorem to calculate the third side. Okay, so if you are given two sides, you must make sure that you use what you call Pythagoras to find the third side, sorry. So now what we're going to do, let's just have an example here. So we are saying here, we know that our longest side, which is our hypotenuse. So this one, we call it hypotenuse. Okay, I think from previous classes, hypotenuse. And if we are to refer to this one as our theta, we are saying this side here will be opposite to the angle, and this side will be adjacent to the angle. So what we are saying here is that when we are looking now for when you're looking for the side, what we must do there, let's see the formula that we must use there. The formula that we must use must be hypotenuse squared is equals to adjacent squared plus what we call opposite squared. If we are finding any of these small sides, if we're finding any of the A or B, we need to subtract what we call one of them again from the hypotenuse. For example, here, if you're looking for adjacent, this is going to be hypotenuse squared minus opposite squared. Then you know what happens here. If you're going to be looking at H now, you will say H will be therefore equal to square root of A squared plus what we call O squared. The same applies here. If we are now going to be looking at A, we're going to be saying root of what we call H squared minus O squared. Now, let's give an example here. If we are, let's say, given the size here, maybe you're given that is maybe here 7, and here it's maybe 10. Let's say we are looking for what we call our x here. So what we need to do here, we'll be saying here, x squared will be equals to 10 squared minus 7 squared, which will be equals to what we call x will be equals to the square root of 10 squared minus 7 squared. Now, if we say 10 squared minus 7 squared is 10 squared is 100. So it's the square root of 10 squared minus 7 squared. We get root 51. So our answer there is going to be root of 51. That will be the final answer there. So we'll be able now to put our value there as root 51. Now, that's what you're supposed to do. So let's move on to the other thing that you need also to remember. Let's say you're looking for the angle, you're given one side. So let's say you're given one side, and angle. Now, when you're given one side and angle, you must now use what call trig ratios. So now use trig Now, for example, here we know that if we have got hypotenuse there, if this one is our hypotenuse, let's say we've got angle theta there, this one is our what we call adjacent. Let me just change the theta there. And so location of theta, let's put our theta there. So it means that this one becomes our opposite and this one becomes our adjacent. Now, we need to remember when we are looking for cos theta, what must we do? Cos theta, we must use what we call it's adjacent over hypotenuse. Then if you're looking for sine theta is going to be equals to opposite over hypotenuse. Then tan theta is going to be equals to opposite over adjacent. So now what you need to do now is that, let's say for example you're given 7 here. then your given angle, angle of maybe let's say 40, what called 7. So you must know what must you do to find what is it, maybe the third side and everything. Let's get to see what we're talking about here. But what I need you to understand is that whenever you're given some questions like this, you must take note what is given to me. You write down what is given to me. Let's see how you're supposed to answer it. Now, for example, here you are looking for AB. You're looking for AB. Now, what you need to do here is that what is given to me, I am given theta. What else is given to me? I'm given hypotenuse. What else? What are they looking for? They're looking for adjacent. Now, what uses opposite? What uses what you call the hypotenuse and adjacent? Which one of the trig ratios uses what you call adjacent and hypotenuse? That one will be cos. So what we know is that cos theta is equals to adjacent over hypotenuse. Why are we putting these two? Because that's what is being asked and that's what we're given. That's what you must do. So let's see here how we're supposed to do it. Now, to solve this one here, you're going to say cos 44 is equals to adjacent over hypotenuse, which is 7. Now, when you want to get rid of the 7 here, you need to multiply by 7 both sides. You multiply by 7 both sides. So it means that adjacent here is going to be equals to 7 cos 44. Now, let's punch and see what we get. So if we say 7 cos 44, what do we get? We get 5,03. So here we can just write here 5,0 what call 4. That's 5,04 centimeters. That will be what called the value of AB. Now let's look at this one here. What were we given? We're given two sides here, and when we're given two sides, what must we do? We're looking for theta here, cos theta, and now we're looking at what is given to me here. I'm given adjacent side. I'm also given the opposite side. What is being looked what called for here is our theta. So here is our theta. So that's the one in question. So we're looking for theta, the size of theta. So we are having opposite and adjacent. So what uses opposite and adjacent in our trig ratios is what called tan. So you're going to say now tan is equals to tan theta is equals to opposite over adjacent. And what is our opposite there? Our opposite is 9 over 8. So that's tan theta. And from there now we're looking for theta now is going to be equals to arctan of what you call 9 over what you call 8. Now we can now go to our calculator. We press shift what you call tan, and we have our fraction here 9 over 8. Then we have what is it? We punch, we get the answer. So it's going to be 48,37. So the theta there is 48,37 degrees. That's what we have. Okay, so what about finding PR? Now with PR now, we don't need to stress here because we are given two sides. When we're given two sides, what must we use? We must use Pythagoras. So what we're going to say here, we're going to say PR squared is going to be equals to what you call what is it? 8 squared plus 9 squared. And here PR is going to be equals to root of your 8 squared plus 9 squared. And what do we get there? We'll get, let's see here, root of 8 squared plus 9 squared is going to be equals to root 145. So it's going to be root 145. That's our length here. That's our PR there. Okay. So that's what you are supposed to do, guys, when you are asked to find this question. Let's look at this example here. This question here. Calculate the size of alpha. So here we're having alpha here, and what do we have here? We are given to alpha according with respect to alpha. With respect to alpha, let's see what we are given here. With respect to alpha here, we are saying our alpha is being asked for. So that's our what you don't have, and what is given here is hypotenuse. It's given. What else is given also is that what we call our adjacent is given. So here we're looking for cos alpha. So which one uses adjacent and hypotenuse is going to be cos. So here we know that cos alpha is going to be equals to adjacent over hypotenuse, which is going to be equals to what we call 6 over 10. Then here our alpha there is going to be equals to arc cos of 6 over 10. And then here, what do we find there? We will say, okay, our cos shift cos 6 over 10. And what do we get there? We get 53,13. So it's going to be 53,13 degrees. That's what we get as our final answer. Now, what about theta there? When you are looking for theta now, we're going to look at theta and say, okay, what is given what call for theta? Okay, when you look at theta, theta is being asked for. What is given to us according to the theta? Opposite side is given, opposite side to theta. What else is given there is what we call our hypotenuse is also given. So what uses opposite and hypotenuse? We know that is sine. So we're going to say sine theta is going to be equals to opposite over hypotenuse, which is going to be equal to what we call 6 over 10. Then here we are saying your theta there will be equals to arc sine of what we call 6 over 10. And then what do we get there is our final answer there. Let's see what we'll get there. So we'll say shift sine 6 over 10. What we get here is 36,87. So it's 36,87. That is our what we call the size of the angle. Okay, now let's move on to next question here that we have. Now, in a triangle ABC, CD is perpendicular to AB. CD is perpendicular to AB. So we can see CD is perpendicular to AB, means say they meet at 90. Then A is equal to theta. There is our A. B is equal to 40. AD is equals to, let's see, AD is equal to 15, and DB is equal to 16. Okay, now calculate the size of theta. Now we're looking for this theta here. Now, if we look at this triangle here, if we look at triangle, let's look at triangle, what we call triangle ADC. What we will see that is that theta is being asked for. But what is given to us is that we are only given, our adjacent. So our adjacent is given, but we are lacking one of the side. We don't have hypotenuse for this. We don't have also here. So which side is easy for us to get now? We can simply get this side here. How are we going to get this side here? Because it's a common side, so we can be able to use this side here, what we call this triangle, to find CD. So here, CD first. So we need to calculate CD first. So if I look at triangle BCD, what we will see is that what is given to us there is angle, which is, can say, what we call angle is given. So angle is given, and what else is given is adjacent is also given. Now, what can we do now to find what we call CD? So now CD is in question. What can we do to find CD? Let's try to find out. To find our CD, we know that what uses CD is an opposite side to the angle here. So what uses what we call opposite and adjacent is what opposite and adjacent, and also theta. So opposite and adjacent, we know that it's what we call is tan. So we're going to say tan 40 is equals to our opposite. Opposite is what we are looking for, over what we call adjacent. Adjacent here is 16. So here, let me just say tan theta is equals to what we call opposite over adjacent. Now we're going to say, okay, our opposite here is going to be equals to 16 tan 40. Now here we can punch our calculator. 16 tan 40. What do we get? We get 13,43. So here is 13,43 degrees. That's what we get as our O. So once we get the opposite side now, we can go back now and say, okay, we now have also the opposite there, and the opposite there is equal to 13,43. Now, we are now going to say which one can we use now to get our theta? Our theta there, we have got adjacent and opposite. So again, we're going to use tan. So what are we going to do? We're going to say our tan theta is going to be equals to our CD, which is our opposite over adjacent, which is CD over AD. Now, what is our tan theta here? Tan theta is going to be equals to 13,43, sorry, 13,43 over what we call 15. Then let's see here, our theta is going to be equals to arctan of that, which is 13,43 over 15. And what do we get there? We'll get shift tan. We're going to have 13,43 over 15. So we get 41,84. 41,84 degrees. That is our value for theta there. Okay. Now let's look at the what we call last example. In the given diagram, ABC is a right angled at C, so we put 90 degrees there. It is given that AC is equals to 4 units. So we are given that AC is here is 4 units. Okay. Then, but tan A is equals 3 over 2. Now, tan is equals opposite of adjacent. So if we are to put this one here, we will say tan A is equals to BC over AC. Now, and what we have is 3 over 2. And what we can just do here to make life easy here is that we just say, because this one here is equivalent proportion, you're looking at proportion here. So we're going to say this one here is equal to you can say 3 over 2 is equals to we are looking for BC here, BC over we'll determine the length of BC without solving A. So BC over 4. So now we're going to say, okay, to get to 4, what did we do there? We have multiplied by 2. So we also have to multiply there by 2. Okay, so that's what with the transformation here, because these are equivalent side, they are equal size, is equal thing. So here it means that this was simplified. So it's simplified. What we call 3 over 2 is simplified already. So we need to find the BC, which is the original value. So if we say 3 times 2, we're going to get 6. So it's going to be 6 over 4. Now, if we look at 6, it means that our BC is equals to 6 units. Okay, so you use proportion here. Now calculate the size of B. Now the size of B, how do you calculate the size of B? So it means that here we've got 6 already here. So we can put our 6 there. Let me just put it in a different color there to show that we have we looked for it. Now here, so we come back and said, okay, we are looking for B. So when you're looking for B is an angle there. And now when you look at B, what is given in respect to B is opposite and adjacent. So it means that we're going to use tan. So because tan is the one that uses both of them. So we're going to say tan B is going to be equals to opposite over adjacent, which is equals to 4 over 6. Now B is equals to, so we put that one here, tan B is going to be equals to arctan of 4 over 6. Now, if we do that, let's see what we get here. We say arctan of 4 over 6. We get 33,69. So we get 33,69. Okay, 33,69. And here, determine the length of AB. I'm gonna do this one here, guys. Please, I'm gonna do this one. What call in this space here that we have there. So in this space that we have, we're going to have let me use another color there. So let's continue with the red there. Now, or green. Now here we are going to look for AB. AB, we are going to use Pythagoras here. We know that AB squared is going to be equals to BC squared, what call plus AC squared. Then here, what do we get for AB there? We're going to use your 6 squared plus 4 squared. So we are saying AB there is going to be equals to root of that. Then let's see what we get here. A root of 6 squared plus 4 squared is equal to 2 root 13. So it's going to be 2 root 13. That's our final value like that. Okay, so here we can put our value there, 2 root 13. Okay, so done deal here. One, the first one here, we go to the second one. Then we go on to the to the third part of the question. Now let's see what will be the next question now. So this one here is your practice work. So you can practice this and submit what called to me on the WhatsApp numbers that you see on the first slide. Okay, thank you so much. Until next time.